Key features of quadratic equations, part 1. Okay, so here are all the notes on what each of these key features are. We got domain, range. We worked a little bit with that already. Increasing intervals. So we didn't do really this. We talked about end behavior before, but increasing interval is just saying when x increases, y increases. So if you look at my hand here, it's like when it's going up. Okay, that's an increasing interval when it's going up. And then the decreasing interval is when it's going down when you read it left to right. Positive interval, this just means when the y values are positive, which means when the graph is above the x-axis. Negative interval is when the y values are negative, or in other words, the graph is below the x-axis. And the end behavior here is where the graph goes or approaches for very large positive and very large negative values of x. Okay, so a lot of key features going on here. So number one, let's start off, number 1A, let's start off with the domain. So the domain is the possible x values. And since there are arrows going on here, and they're going to continue to go all the way out to both sides, there is no restrictions on the domain. The domain, we're going to say, is x can be all real numbers. All real numbers. Now, the range is not that. Remember, range is our y. It's our up and down, right? The range is up and down in our y. But here's the thing with the range for this graph. It's never going to go above 8, right? The highest it ever goes is 8 for our range, right? And then it just goes down from there. So the range, I'm going to say, the range is that y needs to be less than or equal to 8. You know, it goes 8 and everything below. So y, the range is y is less than or equal to 8. Next is the increasing interval. So we're trying to figure out where in the graph does y increase as x increases. So we're going to be reading this left to right because we're looking at as x increases. So I'm going to kind of shade the parabola a little bit. So if I start at its leftmost spot, it looks like it's increasing, right? It's going up, 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 up this entire time, right? It's increasing. Little arrow, it's increasing. And then once it hits, and this is the special spot, once it hits 1, it starts decreasing down, 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 down as we read left to right. I'm going to draw a little arrow there. So its increasing interval is when x is less than 1. And its decreasing interval is when x is greater than 1. And when we're defining these intervals, we're always looking at the x, okay? So when x is less than 1, it's increasing. And then when x is greater than 1, it's decreasing. So I'm going to erase this visual here to answer the next key feature. Okay. Next is positive interval. So that just means when the y values are positive. Or in other words, when the graph is above the x-axis. So let me just bold this x-axis. The graph is above the x-axis here. That spot. This is the entire time. Let me shade it in blue. It's above that's when it's positive. Just positive. It's not talking about increasing or anything. It's just that's when it's positive, is when it's above the x-axis. Well, when is it above the x-axis? Between -1 and 3. So I'm going to write that as positive between -1 and 3. Okay, so I'm looking here. -1 and 3. That's when it's positive. Now, the negative interval is when it's below the x-axis. So I'm just going to shade it in black. That would be here and here. That's the negative interval. There's 2 of them actually on this one. And how I would define that, the negative interval is when x is less than -1. That would be this spot over here. And when x is greater than 3. those are the two times it's negative. When x is less than -1, that's over here. And then when x is greater than 3, that's over here. Those are the two times that it's negative. Do a little erasing again. Sorry. The last one's talking about end behavior. So we're looking at it when it at the end of the graph where the y values go as we go to large values of x and small values of x. So the first blank we have is x goes to positive infinity. Where does y go? Well, positive infinity for x, right? This is our x-axis, is out here, right? And negative infinity for x is to the left. So positive infinity is to the right, and negative infinity for x is to the left. But if we look at the parabola in terms of its y, as x goes to positive infinity, as we go out this way, the graph is going down to negative infinity for y. So I'm going to put negative infinity. So y is going down. It's going down to negative infinity. Even in the other direction, as we go to negative infinity for x, it's still going down in the y direction. This is also going down to negative infinity. So the end behavior in both directions, not only in positive, not only to the right is down to negative infinity, and to the left is down to negative infinity. In both directions, the end behavior is negative infinity. Let me show you another example. So this one actually opens up. So it's going to have different end behavior, right? It's going up, but we'll get to end behavior at the end. Domain, again, arrows, both directions. It's going to go on forever in the right direction, forever in the left direction. The x values, it's never going to stop, be all real numbers. But it's not the case for the range. The range is never, going to go below -18, right? The y. It's -18 and up. So the range, we can state that y needs to be greater than or equal to -18. If it was below -18, we'd say less than or equal to -18. But it's above -18. So all the possible y values would be greater than or equal to -18. And yeah, don't ever forget domain is x, range is y. And for all these other things, we're dealing with x. We're always looking at x. Okay. Next one says increasing interval and decreasing interval. I'm going to do those together. So remember, you read these graphs left to right. We're talking about as x increases, what happens to y. So we're reading it from left to right. So if I start here, it looks like it's decreasing, decreasing, decreasing. It's going to shade that. So with an arrow, it's going decreasing. And then once it gets to an x value of 2, then it starts increasing, increasing, increasing. So the decreasing interval, or sorry, the first one says increasing. So the increasing interval is when x is greater than -2. And then the decreasing interval is when x is less than -2. Again, it's decreasing when x is less than -2, but it's increasing when x is greater than -2. Now, you might be curious as to why I'm not doing greater than or equal to. Well, like at this instantaneous spot here, it's neither increasing nor decreasing. It's constant there. It's not. So that's why we're not including it, but don't let that confuse you too much or anything. Okay, let me erase all of that. Oh. All right, positive interval, negative interval. So again, positive interval is when it's above the x-axis, and negative interval is when it's below the x-axis. So the positive interval is actually two of them, this part and this part. So it's positive in two spots. It's positive when x is less than -5 and when x is greater than 1. Those are the two times that it's positive. And it's negative this whole time that I'm bolding in black. It's negative this whole time. It's below the x-axis. And that's in between. I kind of scribbled it out. That should be a -5 there and a 1 there. So between -5 and 1, it's negative. Let me erase it so you can actually see. Yeah, -5 and 1. This whole time, it's negative. So for your enrichment, again, why am I not including with a less than or equal to? Why am I not putting a line? So at the 1 spot, it's neither positive nor negative. Same thing with at that spot either. It's neither positive nor negative. That's why I'm not including it with the equal to part. But okay. Okay, where am I at now? I'm at the end behavior. Okay. Now the end behavior on this, guys, it's going up in both directions, isn't it? It's going up in both directions. So as x goes to positive infinity to the right, it's going up to positive infinity in the y. And even the other direction. As x goes to negative infinity to the left, it's still going up to positive infinity. So in both directions of x, to the right, and when x goes to positive infinity to the right, it's going up to positive infinity. And even on the left, as x goes to negative infinity, it's still going up to positive infinity in the y. The end behaviors in both directions are positive. Okay, so I'll let you practice more with the graphs with these behaviors. Now, I'm going to help you sketch number 2, 3, and 4 just as like a review of finding all these features because what it says here is sketch a graph for the following quadratic functions by finding the axis, symmetry, vertex, and roots. And that's going to help us fill out this table down here for the end behavior. So this is kind of review. If you can go back to the earlier lessons for in this unit, and this one's actually from standard forms, actually from the previous unit, to get a more in-depth look on how to find these features. Okay, so I really just want to find these things: axis of symmetry, vertex, and roots. So to first find the axis of symmetry, it's negative b over 2a. So I'm going to write AOS just for axis symmetry, so you know what I'm doing. Negative b over 2a. So it's going to be negative 2 over 2 times 1. And this is more or less review, so I'm going to go with a little bit of speed. So that would be positive 2 over 2, which is 1. So the axis of symmetry is at 1, so that's going to be important. So let me draw that. Now I need to find the vertex. So remember, the vertex is on the axis of symmetry. So I am going to plug in the axis of symmetry for x. So I'm going to find f of 1, which would be 1 squared minus 2 times 1 minus 15, which would be 1 squared is 1, 2 times 1 is 2. So that is 1 minus 2 is negative 1 minus 15, negative 16. So the vertex would be at 1 comma negative 16. So let me go plot that. The vertex would be here. Okay. So I know that's where it's going to, change from go decreasing to increasing because it's going to open up because of the positive coefficient. Now I just need to find the x-intercepts because that's going to help us with the positive intervals and the negative intervals and whatnot. So find the roots. Remember, that's just x-intercepts. Put 0 in for y, or in this case, f of x. And then we have to solve this. So we could use the quadratic formula, but factoring should be pretty easy on this one. So it's going to multiply to negative 15, add to negative 2. That would be minus 5 and plus 3. So then my roots, and you can set them both equal to 0, right, and solve, but then I know the roots are going to be positive 5. I don't really need to do that whole math. And the other root would be negative 3. So 5 and negative 3. Okay, so this is what it would look like. I'm going to let you fill out the table. Okay, you fill out the table. I'm just going to help you with the graphs for them. Okay, I'm going to let you fill out the table, try to determine all those intervals and whatnot, but I'm just going to help you graph them. Okay, just kind of as a review. So number 3, this one's in vertex form. So the vertex is easily identifiable. The vertex is going to be at, remember, it's opposite of what's in the parentheses and then the number on the outside. So that'd be negative 4, comma 8. That's the vertex. So let me plot that here. And I have an idea that this is going to open down because of that negative leading coefficient. And so the axis of symmetry, though, let's sketch that. Remember, the axis of symmetry goes through the vertex, right? So let me scroll back down to this. So the axis of symmetry is going to be at negative 4. So let me just write that out. Axis of symmetry is going to be at x equals negative 4. So all I really need now is the roots. I got to figure out where it crosses the x-axis because that's going to help us determine those positive and negative intervals. So I'm going to set this equal to 0. I'm trying to get the roots now. So set it equal to 0. And then solve this. So I'm going to subtract 8 from both sides. I'm going to have negative 8 equals negative 2x plus 4 squared. Let me show the full work, actually. So I'm going to subtract 8. Let me just show the steps. Then that whole quantity, x plus 4 squared, is being multiplied by the negative 2. So I'm going to divide by negative 2 to get rid of that, which would be 4 equals x plus 4 squared. Then I'm trying to solve for x here, and that whole quantity, x plus 4, is being squared. So to undo that, I'm going to take the square root to start to solve for x. Square root of 4 is plus or minus 2. And then I just have x plus 4 here. To isolate x, I just need to subtract that 4 away. So I'm going to subtract 4. So what I'm left with is x. And then usually you put the negative 4 in front for math notation purposes. I'm going to do that. So I have negative 4 plus or minus 2. So I'm going to do negative 4 plus 2 and negative 4 minus 2. So x is going to equal negative 4 plus 2, which is negative 2. And then x is going to equal negative 4 minus 2, which is negative 6. So those are my roots, negative 2 and negative 6. This and this. So the graph is going to look something like this. And again, I will let you fill out the table and do all that good stuff. Okay? All right. And then let me, again, this is just kind of review. If you need more in-depth and more practice with this, it's in previous lessons. So this one's in factored form. And what's great about factored form, it gives you the roots. So the roots, whoops, erase that. The roots, remember the opposite of what's in these parentheses. Those would be our roots. So it's going to be negative 1 and positive 7. So if I'm going to plot, I'm going to go ahead and plot those. There and here. Now the axis of symmetry, right, is always in the middle of the roots. So you can kind of eyeball it. Hopefully you can eyeball it with me. It should be at 3. But let's say you're not good at eyeballing it. Remember, you can just add the roots and divide by 2. So let me write that. Axis of symmetry. If you just add the roots and divide by 2, that'll get you the average of the two numbers, which is 6 divided by 2, which is 3. So that's the axis of symmetry. Let me write it more properly as x equals 3. Those are the roots. And then I need to figure out where on the axis of symmetry the vertex is, because I need to figure out, this is going to help with the range. I kind of figure out where it is and where it is on the axis of symmetry. But since it's, on the axis of symmetry and the axis of symmetry is 3, I just need to plug 3 into the equation to figure out where on that line it is. So let's do, again, I'm finding the vertex. So let's do h of 3. 3 plus 1, and then 3 minus 7. So 3 plus 1 is 4. 3 minus 7, that's negative 4, I think. Okay, so that would be 3 times 4 is 12. 12 times negative 4 is negative 48. Okay, so the vertex would be located at 3 comma negative 48. So let's plot that somewhere down here. That's good enough. So here we go. That's what it's going to look like, and I'll let you do all the table again, okay? So good luck with all that. I'll let you do the rest.